We're going to solve the equation two cosine squared x plus cosine x is equal to 1, and we're going to solve it on the interval 0 to pi. So we're solving it in the first revolution of the unit circle. So the first thing we're going to do with this equation is we are going to get 0 on one side of the equation. So I'm going to subtract 1 from both sides of the equation so that 1 will cancel out. And I'm doing that because this is a quadratic equation, and if we can, we like to solve quadratic equations by factoring. And it's best to factor when you have 0 on one side of the equation. So I like to write out to the side not just what I'm doing, but why I'm doing it, so that when you're replicating these problems and doing your own examples, you have an idea of what to do. So now we have 0 on one side of the equation, and the only trig function that shows up in this equation is cosine. So I'm going to introduce a new variable just to make it easier to look at. I'm going to let a equal cosine x. So now instead of 2 cosine squared x, I have 2a squared. And instead of plus cosine x, I have plus a, and my minus 1 stays the same, and all of this is still equal to 0. So that just looks a lot more aesthetically pleasing. And it's now very clear that this is a quadratic equation. So we are now going to factor. Notice that we have a 2 in the front here. When you have a coefficient in the front of the a squared term or the x squared term or whatever it is, you can't just find two numbers that multiply to -1 and add up to 1. That is not going to work if the leading coefficient is not 1, which is not in this case. So I am going to factor by grouping. If you feel super comfortable factoring, then you don't have to factor by grouping, especially when the leading coefficient is not 1, but I like to do it this way. So I'm going to multiply the 2 and the -1, the leading coefficient and the constant term, to get a -2. So now I'm looking for two numbers that multiply to -2 and add up to +1. And the two numbers that do that are a +2 and a -1. So I'm going to use those two numbers to rewrite that +1a term. So I'm going to keep the first term the same, of 2a squared, but I'm going to rewrite the +1a as +2a minus 1a. So these two terms right here replace that +1a. And then I'll bring down the -1 equals 0. And the reason that I did that is because now I can group this into two sets of two terms. So I have the orange terms and the green terms. Just looking at the orange terms, the 2a squared plus 2a, they have a 2a in common that I can factor out. That's going to leave me with an a plus 1. And the -1 minus 1, they have a -1 in common that I can factor out. That'll leave me with a positive a plus 1. And all of that is still equal to 0. Now both terms have this a plus 1 that shows up, and so I'm going to factor that a plus 1 out. And then we'll talk about what's left in orange and what's left in green. What was left in the orange term when we factored out the a plus 1 was a 2a, and what's left in the green term when we factored out the a plus 1 was a -1. So now that we have this factored, we are going to set both factors equal to 0. So I'm going to set the a plus 1 equal to 0, and I'm going to set the 2a minus 1 equal to 0. Here we're using the zero product property. So I'll solve both of these equations, subtract 1 from both sides in the first equation to get a is equal to -1. In the second equation, I want to get a by itself, so I'll add 1 to both sides, get 2a is 1, divide both sides by 2 to get that a is a half. So I have a is -1 and I have a is a half, but that's not our solutions, because remember, way back up here, we let a be cosine x. So this is really cosine x equals -1, and cosine x equals 1/2. And now we're looking for what those x values are. What are the x values where cosine is -1, and what are the x values where cosine is 1/2? So the cosine represents the x coordinate of the unit circle. I'm going to draw a rough sketch of the unit circle here just to help us visualize our solutions. It's a perfect circle. Okay, so cosine's the x coordinate. The x coordinate is 1/2 up here. That's the point on the unit circle, and that happens at pi/3. And the x coordinate is also 1/2 down here at 5 pi/3, where the point is 1/2 -√3/2. I'll also write these radian measures in degrees, so that could be pi/3 or it could be 60 degrees, and this is 5 pi/3 or 300 degrees. So that takes care of where cosine is 1/2, and cosine is -1 right here on the unit circle at the point -1, 0, where we have pi radians or 180 degrees. So if you're writing your solutions to these equations in radians, you would have 3 solutions. Cosine is -1 at pi, and cosine is 1/2 at pi/3 or 5 pi/3. Those are the 3 solutions between 0 and 2 pi in radians. Or you could write the solutions in degrees as 180 degrees, 60 degrees, or 300 degrees.